I work in different, developing different software solutions that uses AI. More specifically, generative AI nowadays. I'm sure you are already aware of how AI has advanced in recent years. You can see that effect in every fields like business, government operations, research, and definitely in education. As the demand for the AI is growing, everybody is trying to make some use of AI in their career, right? Starting from the freshers in engineering college to the top executives, also trying to understand the technology and gain most of it, of this technology in their involvement. Like student wants to use this technology to learn and do stuff, and the executives are thinking that how can we use this technology to make a better product of what we are, or give better service to people. A similar thing is happening in research also. uh, this is particularly a very significant year for AI because as you know that in this year, uh, Geoffrey Hinton and his colleague, and also a few other people have received Nobel Prize in physics and chemistry. Sorry, please mute yourself. I mean, mm, to avoid the noise. Okay, so like I was saying that with this kind of advancement that we have, it's a great time for AI. Like this year in in physics and chemistry, both people have received Nobel Prize because of their contribution in AI. Nobel Prize was particularly considered for contribution in theoretical sciences, right? Theoretical sciences and humanities like this. But AI and AI related research has been awarded. So you can see that how the direction of the demographics are going, where basically this is going. So definitely this is a good year to start uh, learning AI. Maybe in this particular audience there are a lot of a lot of people who already have worked in AI and they are more expert than me. It may also happen that there are few people who are just starting the process of learning AI. So I will try to kind of present everything that I have planned today in such a way so that all of you can get some idea from different layers of complicacy in this technology, right? Particularly, I will try to explain and focus on generative AI because generative AI is now the talk of the town. So, giving a little bit of idea of how generative AI works would be great for us, at this level. I want to make it a very interactive session. So, if you have any questions, you can let me know, and I will try to answer them as much as possible. While I will be presenting this content, it would be difficult for me to pause the content and come back to the comment box to check the comments. So I will solicit that unmute yourself and ask a question. I won't mind that at all, right? Also separately, I will dedicate some time at the end of the session to take the questions and try to answer to the best of my knowledge. But you can do that in between also. Okay. So I will share my screen. Please let me know whether you can see my screen or not. Mm, just a moment. Right. I hope you can see my screen, right?
Yes.
Perfect. Okay. So as you can see, as I said, that the topic as discussed, as declared before, is gentle introduction to generative AI. Now, I am not sure how gentle is this going to be, but I try to put this in a green color just to assure that I will not go very technical here, in order to explain stuff. But it's very difficult also that explain everything without, going in much technical details. So I will start with this famous quote from Geoffrey Hinton. Possibly now he's very famous for, he's Nobel Prize winning. But apart from that, he was very famous for us, while we were learning the deep learning, particularly. So what he said, right? We will start with that. The paradigm for intelligence was logical reasoning, and the idea of what an internal representation would look like was, it would be some kind of symbolic structure that has completely changed with these big neural nets. So this is a very philosophical observation and understanding. This person have invented neural nets, uh, took it to some next level, and he can say things like this, right? He has the right to say things like this. So first of all, I would like to tell you, this part, like paradigm of for intelligence, right? Like how do we define intelligence? That has been a very critical question for everybody. Nowadays, you see the smart devices like, television is smart, the refrigerator is smart, your watch is smart. So when we say smart, we talk about intelligence? What is intelligence then? He's saying that intelligence is logical reasoning. This word, well, this is a little more, uh, mm, elaborative from the particular word intelligence, but it has something to do with reasoning itself. Then the next thing that we want to understand is an internal representation. Would that would be appearing through some kind of symbolic structure. Let's not worry too much about it, but I will explain the part intermediate internal representation in this presentation as much as I can, and then how we achieve this thing. Uh, we achieve these things using big neural nets, right? This big should have more I's and more G's, right? This is not simply big. This is, B with lots of I's and lots of G's. Huh? So it's very big actually. Now, what he wants to say here is that the intelligence is a way of putting things in form of logical reasoning. In order to do the logical reasoning, um, it would be great to have some very effective internal representation. This is again a very crucial term, and uh, this can be achieved through some symbolic structures. Now, this symbolic structure of internal representations can be achieved using many things, but the big neural nets are really doing a great job for this. This is the takeaway, and we will start our detailed discussion with the big neural nets and the internal representation itself. That is why this particular quote is going to lead us the way. Okay. This is a quick look at what I want to discuss today. I will not cover a lot of stuff. I mean, I may skip some of the points here, right? But mostly you look at the beginning that we will try to discuss this, deep learning piece. We will try to distinguish between AI, data science, machine learning, and deep learning. This is a very famous understanding, very famous information.
হ্যাঁ, কি কি হলো কি অ্যাটেন্ডেন্স না
Mute yourself.
হ্যাঁ
Right. So challenges. Then we will. I will try to discuss what are the different challenges of generative AI in business. How do we encounter those problems and what happens? So first we start with some differences. Right. One is uh, okay. So right. So one is artificial intelligence. The second one is data science. The third one is machine learning. The last one is the deep learning. It would be better if I show you this diagram, right? That how these things are different from each other. As you can see, that artificial intelligence is a very generic and a larger set of processes, methods, algorithms, right? Strategies also. A part of it is machine learning, right? So not everything, every methods of artificial intelligence can be called machine learning. Uh, it's funny though, because every time we talk about artificial, we uh, mm, think about some kind of machines, but machine learning particularly is used for a specific field of study. A sub part of this is again deep learning, which will cover most of our discussion today. And then we have some overlap with the data science. Now, data science is a discipline that comes from mathematics and statistics, statistical theorems, corollaries, principles, formulas, and stuff like that. A part of it is called data science, which overlaps with the rest of the disciplines in this way. So if I, there are definitions, so I will not read through these definitions. Just few things like, as I said, it's a this is the general study of artificial intelligence. The general study is called artificial intelligence. You can, so what artificial intelligence aims to do is to, kind of assist or replace human interaction in some works. If the work is very complex, then maybe the AI is still not ready to do that. But for simple repetitive tasks or basic reasoning where is needed, AI can be used to replace that piece, which will increase the accuracy, the time of execution, and a lot of other stuff, and will help us to achieve the goals. As I said, the data science, try to answer, if for some particular data or events, it tries to answer what happened, why it happened, what will happen, and what can be done with the results. So again, I will not exactly go through each of this, but you can see that if we try to observe that, the price of cars are falling, this is an event. So data science can give us some idea that what exactly is happening, why it is happening, and next what will happen. And once I have all these analytical things, what we can do with this. Machine learning particularly try to answer the same things that data science is doing, but using a particularly specific type of models, right? Mathematical models. So this involves a decision process, an error function, or and a model optimization process. So in order to understand what happened, why happened, what will happen, we need to find the pattern within the data, right? And in order to understand the pattern of the data, we need some kind of mathematical model. Now, the basic idea of machine learning, I will be very quick here, and this is the very first technical thing that I'm going to discuss. So listen very carefully. Uh, what essentially we are trying to do here is that in order to understand the pattern of the data, we expose a mathematical model to some data that we have collected from the market or from the domain, whatever that is. That can be different types of data. And we are kind of giving an example, right? Like if you look, at this type of data, then you will observe this. So it's like a pattern. Like if you observe X, then Y will happen. If you observe X1, then Y1 will happen. If you observe X2, then Y2 will happen. This, it is like this. Like if you, it's a very common example. Like if you see the sky is cloudy, then it will rain. So X is sky is cloudy, and Y is it will rain. Something like this. So this is called, supervised learning, right? So the mathematical model looks at the data, the observation and the decision X and Y, and trying to understand the pattern between X and Y. Once it understands the pattern, it tries to kind of look at the new data a new x and try to find what y will happen. If the new x is very similar to the previous x's that we have seen, then we will be successfully predicting what y will happen. This is a huge thing, right? This gives our mathematical model uh, a capability to predict something, right? And how a machine learning um, a model can do that, it will have a decision process. It will have some for some equations, some transformations, which will involve some parameters, some random numbers. These random numbers will be optimized through an error function. I will not go into the details here, but you will get an idea while I will show the later things. Now, using these three techniques, we make a machine learning model that can answer these kind of questions. So if you have some other technique that does not follow this process, then you are still doing AI, but you are possibly not doing machine learning. So the difference is like this. I said that in machine learning, we need one type of model that have a lot of parameters. And based on this parameter, we can say, what will be the prediction, right? So deep learning is a particular study where we make that model bigger, right? Again, a specific type of machine learning model where the number of parameters are even bigger and a lot of parameters are present that can solve a lot of complex problems. So we can see that here uh, nowadays this parameter based models that can learn through an error function um, are actually doing the greatest stuff, right? Whatever AI applications you are seeing nowadays, whether it in your smartwatch or in any weather prediction or whatever it is, it's some kind of deep learning technique, plays a role. So this is a deep learning technique, which is a subpart of machine learning. It's trying to sorry, was that a question? I didn't hear completely. Your voice was breaking up.
So I think someone just unmuted them by mistake.
Okay, okay,
Um,
all right. Uh, that's fine. So moving on to the next part. So this is how these four disciplines are different from each other. When you are, learning AI in today's world, you must understand these different disciplines and how they're different actually with each other. Moving on, I already discussed this. So before I discuss the generative AI, I will talk a little about this deep learning process. Okay. So this is a deep learning. The building block of deep learning is called a perceptron, right? It's a type of neural network. Now, what is a neural network? A neural network is basically something like this. Just look at the diagram to the left. Okay. Suppose I have three values coming from my data. Hmm? For example, say, weather prediction, say it will rain or not. These three values can be something like uh, the humidity, the wind, and the temperature, right? So given these three values, it is coming to, some kind of transformation here. This transformation is basically some sum of products, and the output is like one or zero. It will rain or not. So giving different values of humidity, temperature, and wind speed, we can predict whether it will rain or not. This is called a simple perceptron, which does one kind of classification. Now, what is the classification? Like this. It tells whether it will rain or not. So 0 or 1. 0 means it will rain, 1 means it will not rain. If you consider the share market price, stock price, then whether the stock price will go up, then it's 1. Whether it will go down, it's 0. You can do it in your way. So this XYZ, you can have more than that. Like you can have instead of 3, you can have 300 different values coming in. We usually tell these are the features or the input. Each of them is multiplied with a random number or weight. This weight is called parameter. So as you can see, if I have 3 inputs here, we will essentially have 3 parameters. Okay. So for this particular perceptron, this is called a perceptron, we will have 3 parameters if I have 3 inputs. If I have 30 inputs, we will have 30 parameters here. As simple as that. And all these parameters are, random at the beginning. And when we perform the learning, as I said, with some known data, then these parameters values changes automatically through some algorithm. And finally, we reach a very optimal state where the parameters represents how we can predict the, values. So this is called a perceptron. And this is called the parameters. So you can see that if we increase the number of input, then the number of parameters will grow, right? So let's look at this again. A perceptron is a type of neural network and used for binary classification. I just explained these two terms. Why I'm saying neural network? Because this architecture looks like biological neurons, just like the things that we have in our nervous system, which accepts the, which senses the stimulation from outside, like temperature or, cold or, shock, something like that, and, reacts based on this. So that this thing exactly looks like a biological neuron. So this is called neural network, right? Actually, they are called artificial neural network, contrary to the biological neural networks. So a perceptron is a type of neural network used for binary classification. You can see that, just like I said, that it can classify between 0 and 1. So ideally, it's the input nodes are fully connected to a layer of output nodes. I will explain this, and this is, something that you can skip for the time, for now. But this is a building block of deep learning, a perceptron. Now, if I go to the next slide again, you can see that on the right hand side, I have given a deep neural network architecture. What does deep neural network have? It just have multiple hidden layers, the green ones, right? These are multiple hidden layers, and each layer have multiple units like this. So this one, so inside one circle, you will find an operation like this. So basically, each of these is a perceptron. So as you can see, in this deep neural network, I have 3 hidden layers. Each of these 3 hidden layers have 1, 2, 3, 4, and 5 perceptrons. So here I have 5 perceptron in the first layer. Here I have 5 perceptron in the second layer. Here I have 5 perceptron in the last layer. We also have an output layer. These are also perceptrons. So, these things are combined, in form of a deep neural network. So essentially, a deep neural network have multiple layers, and each layer have multiple perceptrons. So if you just, summarize what is a deep neural network, it has multiple layers, as I showed in the diagram. Each layer has multiple perceptrons, as I said. The volume of a deep neural network is measured by the total number of parameters. So you can see from here that each neuron say have, so you can see that 1, 2, 3, 4, 5 values are going inside this. So you can see that this particular, perceptron will have 5 parameters. Now in this layer, I have 5 perceptrons. Each one of them is connected with all of these inputs. So we will have 5 cross 5, 25 parameters in the first layer, right? Similarly, we will again have 25 parameters in the second layer. We will have 25 parameters in the third layer. So 75 parameters in these 3 layers. Then I have 3 nodes here. So 5 into 3, 15. So we will have 15 different parameters here as well. So 75 plus 15, total 90 parameters will be present in this mathematical model. This is called the volume of the neural network, or the size of the neural network. This is measured by the total number of parameters. You can see this is very simple to measure, right? At least this kind of architectures. So these 3 are basically how we define the deep learning, a deep learning architecture or a deep learning network or something like that. It has multiple layers. Each layer has multiple perceptrons, and the size of the network is measured by the total number of parameters. Okay. Now, the parameters are optimized by a special algorithm called backpropagation algorithm. What is this? What happens, as I said, that there was an error function, right? Now, the error function is measures an error by looking at the known data, right? And and by looking at the error, it try to change the values of the parameter so that the model can correctly predict in case of the known data, right? Some given data, it can correctly predict. If it can correctly predict to some certain level of accuracy, then we say that the model is optimized. It's a big, what I said in just the last two lines actually can take weeks of learning, but for now it is fine. So somehow the parameters changes based on the data you provide, based on the training you provide to the network. So this is called the process of optimization, and you can achieve this through backpropagation algorithm. Deep learning can perform multi-class classification, as I showed here, that a perceptron can only perform 0 or 1 binary classification, but a deep neural network which is having a form like this can actually predict the probability for different classes, more than two. So it can go beyond binary classification. Then it can process multimodal data, like it can process text, it can process image, it can process audio, etc. If the volume of the neural network, deep neural network grows, then we require high computational infrastructure or GPUs so that we can parallelly perform a lot of operation and get the results faster. Otherwise, the model can give very accurate result, but optimizing or training the model or getting a prediction from the model can take a lot of time. Nowadays, big companies like OpenAI, who is famous for the ChatGPT, they are spending billions of dollars in just to run their infrastructure, which is a serious concern. And people are also doing research in this field, that how can I reduce the computation effort by keeping the accuracy same, right? Still, I mean, yes, some success was there, but this is still a very challenging problem, and people are trying to achieve this. Uh, the whole deep learning thing, or the AI in this field particularly, evolved because nowadays the semiconductor research have also improved a lot. So we have electronic or computational infrastructure, uh, which was actually unimaginable in the last few decades. So I mean, these algorithms were actually very old, but we can implement them with such a successful in different type of data, with such a success in different type of data, that was only possible because we have that computation infrastructure. If we don't have the computation infrastructure, we cannot run complex or big models. Okay, so this is the takeaway for the deep learning. I will take a very brief pause here, maybe a few seconds. If you have any questions so far, you can ask me. All right, let's move on. So these diagrams I have already discussed.
Sir,
So
can you repeat the neutral that network?
this
Hello,
one,
sir.
yes, yes,
No, no, sir. Previous one, sir. The defining the deep learning, that neural networking. Can you explain that again?
this one.
What is that? Yes, sir.
So I said a neural network structure looks like this. Now, neural network is a repetitive structure. Okay, it looks like this. Each cell acts like this. So this is a zoomed in version of what is happening in each cell, and this is a repetitive structure. This is called neural network because one unit resembles biological neurons. You have this axon and neurons that actually, works as a synaptic receiver for your nervous system. So something, touches your screen, or heats up here, or cold, or something like that. someone pricks on your skin, they actually receives this kind of signal through this synapses, and they are accumulated together in a body and passes to the nervous system, the next level of nervous system. So this is biological neural structure, but we follow the similar architecture in a mathematical model where each of these values are multiplied by a weight, or a weight is basically a number, a floating point number, which initially takes a random value, and the multiplied values are summed together. This is how a perceptron uh, mm, works. What I said here is the perceptron is a type of neural network. I just told you what is a neural network, and this is used for binary classification, because this summed response, the summed output, if it is above some certain threshold, we can say this is one, um, or if it is below that threshold, we can say this is zero, right? So this is how this artificial neural network or perceptron, one single unit, can do a binary classification. Okay. And a deep neural network basically is a repetitive structure where each cell like this have a similar uh, functionality going within. And a deep neural network is basically a repetition of these layers where each layer have multiple units like this. Now, this whole thing is a unit, right? Consider this whole thing as a unit. It's not that I have four separate units here. This whole thing is a unit. Okay. Does this answer your question?
Yes, sir. Yes, sir. Thank you.
Sure. So let's move on. Now, I said the number of parameters. So I would like to give you an idea of how the number of parameters increased over the years, right? So as you can see that here we have the total number of model parameters, and here we have some years given, right? So somewhere here started studying deep learning, somewhere here. So all these things happened very much in front of my eyes. So you can see that at that point of time. So first of all, this billion is 1000 million, right? I gave you an idea of the small neural network that I have written. It contains 90 parameters only. But an architecture here, you can see that these are the name of the famous architectures like Google Net, VGG16, very famous for computer vision or image related problems. ResNet 50, Exception, Transformer, NASNet, Transformer Big. These are actually very popular models that can work with images and text and stuff like that. Look at their values like 10 to the power 8, 10 to the power 9. So we are reaching this GPT-2, right? This is around year 2019 where we have a model with a billion parameter, right? We have now models of billion parameter. Now GPT-3, this is basically the backbone of your ChatGPT. You all possibly have used it one way or other. The backbone is GPT-3, right? It's now has become GPT-4. So there will be some more steps here, right? But you can see that GPT-3 is 10 to the power 11, right? So 100 billion parameters now. We are talking about 100 billion parameters, which is present in present model. And you can see that you cannot simply run this kind of model in your own machine. However, it will take GBs of disk space and GBs of RAM to store it. And GBs means in hundreds, in thousands, right? So we need GPUs like that to run this massive architecture. But just to give you an idea that how the deep learning has really become deep, that is I gave you this diagram. So you can see nowadays we are talking about models with billion parameters, where only just 9 years or 10 years back we were talking about models even in less than millions, right? So that's pretty much how things have changed within the past 10 years. That is why I was saying that when I was talking about this paradigm of Geoffrey Hinton, I said that big neural nets, this big, is not just a word. It really is something big. So please keep that in mind. Okay. So Now here comes with the advent of models like this with billion parameters, we come to the era of generative AI. I will take a little time to read this passage for you. It has been taken from Wikipedia, but I will like to explain this a bit. So, generative artificial intelligence, it is sometimes called generative AI, Gen AI, or GAI, is a subset of artificial intelligence that uses generative models to produce text, images, and videos or other forms of data. It's very crucial that we understand this term produce. So, this is not just classifying, this is also producing new information. It is producing new things. It is producing new images, new videos, or other forms of data. These models often generate output in response to basic prompts or instructions. I will show the examples. Generative AI systems learn the underlying patterns and structures of their training data, enabling them to create new data. So you look what we just discussed a few minutes back is exactly being presented here. Generative AI system, similar to the deep learning system, learn the underlying patterns and structures of their training data. This is what I was saying. Like by optimizing the parameters, it is trying to understand that what is the latent pattern in the training data, and based on that it tries to generate something similar, right? So just as an example, I will explain that in our childhood, how did we learn painting or drawing, right? We went to someone who is a painter, an expert teacher, who basically shows us, hey, see how this is how you draw a mango. So we follow this path, right? That, well, you have to move your hand, your pencil in this way, and makes a little bit notch here, then go back and make a shape of different things. An apple, you draw an apple this way, you color it in this way. So that is your training data. Someone is telling you that if you want to produce an image of an apple or a mango, you follow these kind of steps. You draw something like this, you move your hands like this, and you get something. Now, also keep in mind that um, when we followed that step, there was always a little bit of noise when we produced our own images. So the mango drawn by a teacher and the mango drawn by a student after following this instruction, that was a little different, right? That is the power of human productivity. So someone can even think of, taking the color of mango, but drawing the shape of an apple and making something new and innovative. People may ask that, well, what is the use of it? I will talk about the use of it later in the later slides. But this is very important that we understand what do we mean by produce text, images, and videos. We are not talking about photocopies here. That is very easy to produce, right? You just look at the structure and you just copy it in another folder or in another file. We are not talking about producing like this. We are saying that, well, this is how someone writes an essay on summer, right? Now look at the pattern, look at the choice of vocabulary, look at the style, look at the mood of the writing, and based on that, write a passage on winter. So we are not exactly following or photocopying the same thing that we are seeing in the training. Instead, we are understanding something from there, some pattern, some structure, and based on the similar structure, we are producing an essay in on winter on a different topic. That is where learning comes. If we only do photocopying, then we are not very intelligent, right? No one will say a Xerox machine who can do photocopy is an intelligent machine because it just produces what it has been given to, right? But we as a human, if we read something and if we summarize that, there is always some new information, new insight comes. Okay, so by what produce is very simple, but what I want you to have is that when you are thinking about generative AI, you understand the word produce from a different perspective. Okay, right? So any question on this definition? It's very important, very crucial. I will show examples of it. how the generative AI works. I will also show that, and then we can proceed further. But any questions here? Fine. So let's take again some notes from here. That is the generative AI. It's mostly a deep learning based solution, right? So how do we create that? This is the strategy, right? What we want to do, but we create that using neural networks from deep learning. Input can either be text, image, video, or audio, or anything. Anything can be used in generative AI. Output can also be same. Now, the funny thing is that given text, I can have image. Given image, I can have text. Given text, I can have video or audio, something like that. So it's not that I'm always talking about a model where the input is text and the output is also text. This is a a cross connection between them. So given text, image, or video or audio, you can have anything. You can either have text, you can either have image, you can either have video, you can either have audio. So doesn't matter. So see how great that is. You can do so many things with this particular solution, particular technology. This is a very specific type of architecture is called, which is called encoder decoder. I will show them how they work. And model size is usually very large, in the billion order, right? A good generative AI model is usually here, is usually residing above this scale. Okay, right? So this is some basic foundation about generative AI. Now, uh, some examples, as I said, that sorry, some examples, as I said, like from text or image or video, we can actually, this is a cross connection relation between them. So some example, text to image. So we can give a description and style, and based on that, it generates an image. I will show example. Text to text. Given a block of text and some instruction generates new information or extracts specific information from text block. Example, given a passage from a document, it can generate a summary. So you have a passage written in English and you are generating a summary. You can say, sir, how this is generating new information, right? If it is summarizes, uh, it is actually summarizing the existing information in the passage, right? Why you are saying new information? New information I'm saying because it is possible that the model can find some insight which is not directly written in the passage, right? This can be done using generative AI. And also it can words that is not present in the text at all. So that also is a new thing that is coming out, which is again revolutionary, right? Image to event. Given a set of images and some instruction, we can generate new images following style and content of input image. Like an example I said, mango and apple. uh, Someone is saying, okay, take the color of mango and take the shape of apple and make a new fruit for me. Okay, so that is image to image, which is again a very productive, uh, you know, uh, very creative version of an AI. I will show examples. Right? Any questions here? Let's move on. An
Uh,
example of how
Partha sir,
generative AI.
we
Yes.
do have a question in chat, and Aditya also has raised the hand.
Okay. So let's have the question. Can someone read the question for me?
I
Where
think
was
I can help you. What is encoder decoder architecture?
it? Good. I'm coming to that in my very next slide. And Aditya,
Sir, if I give an prompt, please generate an image of a dog without a ear. So
hmm.
the model is not giving me the dog without a ear. So what do we can say about that? Why
See,
it
I
is
mean,
giving
it
like
depends on the model. So uh, see, so if you're saying that the model is not giving correct output, that means we are not using a great generative AI, right? Now, acha, give me some time. Okay, I will try to explain this question in a different way. Give me some time. Okay. First of all, let's see what I have written here. I have given a prompt that generate an image of a nice landscape.
So we have another question from Abdullah. He's raised his
Yes,
hand.
yes, Abdullah.
Good morning, sir.
Huh.
Sir, if there is no data in AI related to our topic,
Sorry.
if there is no output data in the AI,
No
what?
output data in AI. Huh?
Yeah,
Okay.
we are into new concept. I think I am a creative designer related
Okay.
to
Sorry, Abdullah, I cannot hear you properly. Possibly there is an issue with the internet connection. Can you repeat the question? I'm very sorry. You can also write the question if that
in AI.
helps.
Can it generate by itself?
Uh, Sorry, I just heard the last part. Can it generate by itself? I missed the first part due to internet connectivity or something, possibly.
If there is no output data in AI, artificial
Mhm.
intelligence.
Acha. Oh, okay. So, first of all, I did not completely understand what do you mean by output data, right? I mean,
A topic which is not in AI.
what I think what you mean is uh, something that is not in the training data.
Okay, can it create by itself?
Yes, it can. See this example. Let's take this example, the mango and apple example. It has the data for mango. It has the data for apple, right? And it is saying that this is mango, this is apple. Now I'm saying that create a new fruit that has the shape of an apple but color of a mango. It can create. But you see, in the training data, it does not have anything like this. So, but say in a situation like it does not have any image of an apple in the training data, then definitely it won't be able to generate this because a part of it does not know anything about the apple at all. So, a combination of the input can create some new output. It's not necessary that the exact output should be in the training data in the very first place. Okay, so that is the power. Like you can have millions of combinations of the data, and uh, based on those combination, it can generate something new, which is a little bit of mixture of everything. So basically, a new thing. Uh, it's basically a mixture of a lot of old things, right? Maybe the style from something, maybe the semantic from something. Uh, let's say you are a creative designer, you said, right, Abdullah? So I will take an example of a font, right? Say a font have multiple things, like it can have a style, it can have a shape also. Now I can take a style from a particular font and shape from a particular a different from, and we can mix it together. A creative human can do that, and so does the AI. Now the new fonts data, we don't need to have it in the training samples at all, but it can generate. I think this will also give the answer to Aditya's question that why image of a dog with no ears is generated. Definitely, this is a lag in the some deficiency in the AI side. It's not perfect. Nobody's saying it's perfect. In some cases, it works. In some cases, it does not work. Right. But if you try multiple AI solutions on generative AI with this particular prompt, some of them will give better result than the others. So, and even if you just repeat the same instruction, maybe it will generate something new. So you can tell GPT that do something for me. I will try at the end of this lecture possibly to generate an image to see whether it gives a dog's image with no ears. Okay, so here what I did is that I said an instruction, generate an image of a nice landscape showing a little boy flying kite. And you can see that this is generated. I have made no manipulations here. This has came out. Now, you can say, sir, this is like a not so realistic image. This is not like a photograph. This is more like a painting or a very crude digital representation. I haven't mentioned any style or anything. There are image generating solutions where you can give those informations and get something new. You can even get a Van Gogh style painting like this, having the same topic, right? So what does it have? It has multiple images where possibly someone is flying a kite in one image, someone flying, there is a little boy in another image. Possibly the little boy is not flying a kite. And then there are landscape also. It just mixes all of them. Now, how it mixes all of them, you need to do a course on that to understand the technicalities. But right now, let's look at this from a black box perspective. Okay. This is another very interesting application, a little from the business perspective. This is an image given, this is, you can see this is a floor plan image. And I'm saying that, well, this is a floor plan blueprint. Can you summarize the floor plan? You see, it is actually summarizing the floor plan. It is saying how many bedrooms are there, how many bathrooms are there, how many living rooms are there, how many dining, I mean, what about the dining and kitchen area stuff? This is actually uh, you know a use case where we generate text from image. So you see, this is basically generating image from text, and this is actually generating text from images. So generative AI working in both the direction. Okay, as I said, it can work in a multimodal environment. It can transform anything to anything. So here we are just doing the opposite. Okay, these are just examples. You can use ChatGPT to do the same. I generated these in ChatGPT. Okay, but there are other solutions also. Also, text to text. Refresh the following passage in a very formal way. I said, existing scoring system for bond recommendation is evaluated based on user preference, blah, blah, blah. You can see that it has actually converted these to a new passage where we have some new information. Like this system assigns different weights to key bond attributes such as yield, maturity, and risk. And you can see that here we have no such information like that. So new information is getting generated from the existing information. This is coming from the learning of the model. The model knows something about bond recommendation and it is producing, right? And this is how text to text generation works. So now you have already seen three different modalities. One is text to image, second is image to text, third is text to text. Okay. So how do we implement a generative AI? Here I will explain the concept of the encoder decoder architecture very quickly. But before that, let's quickly go through this. You don't need to remember all of this stuff, but having these information for the time being can be very interesting. So as I said before, these are basically very large deep learning models, right? Particularly for NLP tasks where we deal with, NLP means natural language processing, where we deal with language data, text data, we tell them large language models or LLM. This is a very popular term nowadays, so I thought that I would include this here, LLM. Number of trainable parameters are in billions. I said this just before, right? So the generative AI deals with billions parameters. That's it. Requires multi-GPU support. An example that this particular language model needs 1944 GB of GPU memory in 32-bit mode. Can you imagine this? GPU memory of 1944 GB. So tremendous amount of computation effort is required to run this. But this is only um, a few billion model. It's not even a 70 billion model, right? So you can see that Llama 2 70 billion model takes up about 140 GB of storage space. Not an easy thing. 140 GB. Just think how many movies you can actually store there. You cannot host such a big LLM in regular infrastructure, as I said. The basic model architecture is encoder decoder based. I will come to that in the next slide. Transformer. Transformers are a special deep learning architecture. You can recall that there was transformer in this diagram. You can see here transformer big, transformer base. They are all here. Now, funny thing is that all these Albert, Transformer XL, BERT, GPT, these are also transformers. These are not just basic transformers, some customized version of the transformers. Okay, so transformers are the building block of generative AI. Okay, transformer was architecture developed by Google long back, not so long back, but yes, at least 6 years, I believe. So LLMs have the capability to produce high quality representation of input text. And here comes the representation. You remember what Hinton said, internal representations. And I said that I will come to this at the end of the lecture. So high quality representation of input text. This is called embedding. For text or images, this is called embedding. The internal representation. This is not the output. This is not the input. This is a transformed version of the input. Okay. And this is called internal representation or embedding. It's a very popular term. Proprietary LLMs are costly if processing large data is required. And, these hosted LLMs where OpenAI or other companies they will charge you for some work. Now, if you want to process a very large amount of data, then definitely it will cost you more. So this is an overall takeaway for generative AI implications. Just keep in mind, you don't need to memorize all this stuff, but just for information. So basically, these generative AIs, three things I will say. These generative AIs are, the building blocks of generative AIs are transformers, which is again a billion parameter model. Two, this basic model architecture is encoder decoder architecture. It's just a strategy of how I write the code. Third, you need hosting in a very efficient infrastructure to start predicting or start training these kind of models. So you cannot do that in your own machine. Okay, you can only use that. I will walk you through this encoder decoder architecture quickly because that was also one question. But any questions so far?
Partha sir, we do have question in chat.
Mhm.
One question was, can we create plagiarism free image?
Whoever have asked this question, I think he or she also knows the answer a bit, right? Right? uh, it's very difficult to say. I don't have a direct answer, right? As you can see, first of all, the training data that is used, there are copyrights on the data. So only those data has been used where the publisher of the data said that yes, you can use it for training. Now the output that is coming is from the training data. So yes, it's a copy. It's it's somehow a mimicry of the training data. So yes, in a way, it's plagiarism. It's definitely plagiarism that is coming from the input data. But as the input data license has already been ensured, there is no legal problem there. This is the best I can say. But theoretically, it follows the structure of and pattern of the input data. So that is why we cannot officially say this is plagiarism free, but plagiarism generally means you are copying somebody's content without their permission, which exactly is not happening here. Does that answer the question? At least to some extent. I am not defending, generative AI.
Right. So sir, we do have another question. What did it mean by vector database?
Where from that came? Vector database, I never said that anywhere. Okay, let's see. I mean, vector database, yes. So I said embeddings, right? The embeddings are basically an array of numbers. So if you store this array of numbers in a database, then that is a vector database. Okay.
Sir,
I
on
have.
the previous question, the plagiarism one, there is a answer. But what if the image is not generated from the input and it is generated from the prompt? Then it is plagiarism,
Yeah,
plagiarized
of
image.
course. Oh, very good. This answer I know. If you give a gun, if you make a gun, right, and you give it in wrong hands, then it's not the problem of the gun. right? Prompt is not given by AI. Prompt is given by the person who is using the AI. So there goes my answer. Is it clear enough?
No reply
My
yet.
po-
Yes,
my
but there
point
is.
is
Uh-huh.
my point is, I mean, we cannot accuse AI for generating a plagiarized image if you uh, use one in the prompt. It will follow your instruction. But there are policies in AI, generative AI, that, suppose you want to generate a passage blaming some community, then the generative AI actually can tell you that, see, I cannot do this because this is against my generative policy. So there are some guardrails, which is not complete, but people have taken measures against it. But see, it is you who have told the model to generate some bad things, right? So this is your responsibility. Not, I will not blame AI for this.
Right. Sir, we have another last question. How different is transformers and encoder and decoder?
Okay, just 1 second. Uh, just 1 second, huh?
Right, sir.
My God. Ah, right. Okay. So, very nicely explained. What I nicely explained? I don't know.
The gun
Okay.
example.
Oh, maybe. Yeah. That's my favorite example. Chalo. Okay. So the difference between encoder, decoder, and transformer. See, encoder decoder is not a deep learning model. It's a style of the architecture. It's a floor plan. It's a floor plan, and a transformer is bricks. Okay. To put it simply, encoder decoder is a floor plan of your network. It's not the network actually. It's the plan, how you will design your network. It's saying that you make one stack of architecture that you name as encoder. You make another stack of architecture, another architecture or stack of model that is decoder. These two can be same, these two can be different. But these are, no one is saying anything about what is the internal principle of encoder decoder. You can make encoder decoder using transformer architecture. So transformer is a deep learning architecture. That's it. Some perceptrons aligned in a particular way. This block can be used to build encoder, and this block can be used to build decoder. Encoder decoder architecture is the floor plan, the blueprint, and the transformer is the brick that you use based on the floor plan to make a room, make a building. Okay. So this is what I'm saying here. Purpose of encoder is to take the input and make some internal representation. This is called feature vector or encoding, but it's better if you say this is internal representation. Okay. It's better that if you say this is internal representation. Now, again, the term internal representation came here. Again, the term came, internal representation. And you see, the purpose of the encoder is very clear. You don't worry about the output. You understand the input data itself, right? You understand different parts of the input data. When I'm giving you a picture of a mango, you understand different things in it. So this EX, which is the internal representation, is basically some numbers, an array of number. Maybe one particular number represents the shape of it. Maybe another number represents the color of it. Maybe another number represents a combination of both. We don't know which number represents what, but the internal representation is for internal use only. It understands the input so that we can present different features of input using different numbers, right? This is fine for now. So this is your internal representation coming through encoder. Now, decoder accepts the internal representation and generate something else. Decoder has no dependency on encoder at all. It just takes the output from the encoder and starts generating uh, the output as the user is looking for. Okay, so the internal representation is generated by the encoder, which is consumed by the decoder to produce the output. So decoder does not see X, does not see the actual input data. It just looks at the minimal representation or the effective representation of the input. This is what encoder decoder is all about. Okay, I will give an example in the next slide. Uh, it's a little complicated example, but think it in this way. Forget all these things here written here, right? What I'm saying here is that suppose a user has given some input text, something is written here, blah blah blah. This is my encoder. The encoder converts them to some feature. This is your internal representation. This is your decoder. What I mean here is this: using the internal representation by the encoder, it can perform different tasks. One task is unsupervised learning. I'm not telling what is this. This is basically clustering. Another task is classification. Another task is generating new text. So the same encoding or internal representation can be used by the decoder to perform different tasks. So you can see that the generative part is very much dependent on the decoder itself. But the encoding is also equally important because somehow we need to represent the input in some suitable, meaningful internal representation that the decoder understands. Okay, so you can see that text feature extraction, this is the encoding part. Text classification, this is the decoding part. Text generation, this is decoding part. Now, GenAI for text and NLP is about generating news text or generating new information. So it essentially have a encoder part, which takes the input, the prompt that you are giving, the instruction or the associated data that you are giving. It processes and converts them to some internal representation. Then the decoder steps in and generates the output as your own. So if I do, I have anything? No, perfect. So if I so what is happening? This input is going to the encoder, getting converted to a nice mm, internal representation, right? And then uh, this internal representation is transforming to this image by the decoder. So here, from here to here, I have the encoder converting this text into internal representation, some numbers. This number is taken by decoder and decoder is generating this. Decoder does not know what I have written in form of text. Okay. Some examples are here. I don't want to kind of iterate through this. For marketing, definitely, let's look at the healthcare. So intelligent medical documents and transcripts. What say, like you go to a doctor for some health issues, doctor analyzes you, writes the whole diagnosis in a report, stores it somewhere. Another person comes and the hospital have say hundreds and thousands of such medical records. You process them using a large language model. Now you have an intelligent agent. So a new person comes with some new symptoms, with some symptoms. We hit the symptoms. We ask the intelligence system that based on the records that you have, what do you think the person is facing? 90% of the time, the agent will give you a basic idea that what is going to happen. What would be the diagnosis? What the person should do next? It's a proven fact. I'm not saying 90%. It's not a made up number. It has been proven through different researchers. So it's good. It's working. Content generation for the creative directors here, generating content based on specific user requirement, machine translation for multilingual support, multimodality of content. Suppose you want to make an advertising pamphlet for English and Portuguese. You don't know Portuguese. What you will do? Will you go to some person, a translator who knows Portuguese? Maybe you don't have anybody in your city. It may happen. We don't do that these days. We simply go to the deep learning model, the generative AI model, say that translate this into Portuguese, and voila, we have something. It may not be very accurate, but it is doing your job very quickly, right? These things are happening. So I will not, read out each one of these, not very useful, but I think you generally, got the idea. So there are two types of LLM tools. This is the end of my, almost the end of my lecture. I have taken long enough. This is, there are two types of tools, proprietary tools and open source tools. Proprietary tools means um, some organizations have built that model, trained the model, hosted that model using GPUs and everything, and give you some kind of interface like ChatGPT to interact with the model, which you can use. Open source models don't have that kind of thing. You need to have some programming language skills to implement them at some level. But the advantage of that is that if you have some uh, architecture, you can use small models here. Definitely, you cannot host an open source GPT in your machine, but smaller models can be hosted now in open GPU platforms. Right. So if you come to this domain, if you start programming, you will learn all this stuff, that how to host these open source things. Sometimes it's very crucial for a business solution to have open source thing. I mean, that you can host in your own machine, because when it goes to another organization, there are issues that what they are doing with the data. People may not like sending the data to ChatGPT all the time. We get that kind of request now and then. I won't spend too much time on this LLM frameworks. It can be too complicated for this. Uh, Rather, I will come to this. Right. So, what kind of providers we have? OpenAI, they have these kind of models. This is a proprietary framework. Anthropic, proprietary framework. Falcon, Facebook, Databricks, Google. Google, this is, you can host this. This is open source framework. Cohere, Salesforce is not open source. So, I mean, these are different LLM providers that you have. Framework means basically, a programming infrastructure. You don't need to know much about this. So you can use any of these models in these frameworks to get the results. This just ease the effort of programming. Evaluators, how good your LLM performing. Just like someone said that started, um, I gave an instruction that generate an image of a dog with some attribute, but it is not doing exactly. So the LLM is not doing very well. So LLM evaluators are, platforms that kind of tell you how good your LLM is doing given the instructions. Okay, so these are some names that you can definitely use, to explore stuff like this, right? Uh, you know that's pretty much it. I have a few more things, but this is not exactly for you right now. um, in- like we can explain in maybe some, if we have some advanced uh, workshop on this, we can discuss these things, these on LLM agents, particularly how do we process the text data and questions, stuff like that, but which can come later. Okay. uh, so I will actually close my session here. Uh, right. I think I tried to cover the general concept of generative AI, how deep learning is involved with that, how deep learning is different from machine learning, AI, and similar disciplines. What is encoder decoder architecture, and how do we use it in the generative AI generally to produce some results. This was, as I said, that my objective was to give a gentle introduction. That is why I skipped a few slides here and there. But I believe in general, you got an idea that how the generative AI works. Okay. I will not say anything else. I already skipped a lot of time, but I guess I consumed some questions in the meantime. But you can still ask me questions if you have any. But I will not extend this lecture anymore. Thank you. Thank you for your attention.
Thank you, sir. And participants, I think you can raise your hand if you have any questions. I shall unmute you and ask the same. And please fill the feedback form we've given in the chat.
I will try to answer some questions in the chat.
Partha,
Okay.
sir, we do have a question, yes, in chat.
Yes.
In embedded, which language should we prefer, Python or C++?
I replied it. I said Python because see, Python has a lot of libraries nowadays to do that kind of stuff, right? So that is why I say Python. Not that C++ is inefficient, but we simply lack a lot of libraries. So you have to write a lot of code in C++. That's all. But again, I will say Python is fine. Partha, you have some questions.
Sir, in machine learning, which library should I know? Like NumPy or Pandas or TerraFlow?
It's actually not like that. See, you need all of them depending on the problem. NumPy does a specific type of processing with numbers, arrays, and stuff like that. Scikit-learn have its own package for libraries for doing stuff, implement different algorithms. Not everything is present in his NumPy. So it will be a combination depending on the requirement. Okay. So a combination of, Keras, Scikit-learn, NumPy, these three is sufficient for most of the basic solutions of machine learning and deep learning also. Basic solutions. Does that answer your question? Someone said, Aditya, why does okay. Thank you, sir. Aditya's question, what was that? Why does these models show hallucination and how we can reduce this? Now the questions are coming that I cannot answer here. Simply, the answer is too big. Simply, the answer is too big. So what? Lots of questions coming. I need some help here. For multimodal data training, could you please suggest the GPU size? Depends on the volume of the module, but Google Colab suggests, gives you a T4 GPU, which is fine for small LLM models, right? And that is free. You can experiment. Sir, what do we need to learn for a career in ML and AI? What projects do we see? I think now the questions are coming that Shafila can better answer. So over to you, Shafila.
Thank you, Partha, sir. It was actually a great session. Thank you, sir. So I'm just sharing my screen.
Okay, Shafila, so I will drop off. I have a lot of stuff to do.
Right, sir. Thank you so much, sir.
So please share my email ID to...
Your email ID, sir?
So it was actually in the last slide. I will... okay, so my email ID is partha.s@tatrasdata.com. Please share that with them, Shafila. So if you have any questions, you can reach out to me. I'll be happy to answer them. I will see if I can, send this presentation to you somehow.
Right, sir. Okay. Right. Thank you, sir. Thank you so
much. I will take your leave. Thank you. Thank you for your attention.
Thank you, sir. So, Priyanka, my screen is visible?
Yes, ma'am. Yes.
Okay. So many students, they were asking about courses or programs related to AI or data science. So Subodh, in collaboration with STPI, offering you a program in data science and AIoT. So this is the selection procedure for the program. We are open for the registration for the new batch since 8th of October, and the last date for registration is 25th of November. And we are in the process of registration. The whole internship program will be of 6 months duration, and we run this program online only. And we do give internship in two programs. One is data science and second is IoT, Internet of Things. So in this process, like right now we are taking the registrations, but after the registrations are closed, we will be taking your aptitude test. So these are two mandatory steps. One is aptitude test, second is interview. So those who clear the aptitude test, they will be called for the interview, and then onboarding will be there for those people who have cleared the interview also. Currently, we are running our data science batch number 13 and AIoT batch number 8, in which we do have 200 students for data science, and we do have we do have very limited seats for AIoT, I would say, and we do have 20 people, 25 people right now in AIoT. So this is the, a brief of the curriculum that we teach in DS. We start with Python programming, then we run machine learning, data structures and algorithms, data IQ certifications, deep learning, natural language processing and recommender systems, and a passion project. For AIoT curriculum, we start with Python basics, foundation of electronics, embedded computing, Android development, cloud computing, machine learning on microcontrollers, and a project. So there is a question in chat also. I hope this slide serves the answer. So duration of both the program is 6 months, and it's a full-time program. We do have a part-time program also for the data science, but that is like if you want to learn a particular module. I mentioned few modules in data science. So you can, come to us and learn Python programming, and you can take the certificate. But we do take the live classes, and all the classes are taken online. But yes, we do record the sessions and put those recorded sessions on our EduClub, which is our learning platform, and you can have a look for the for those sessions. So duration of the month program is 6 months, and this is the time commitment that this rigorous program wants from you, that is 48 hours per week. We do run classes like 2 to 3 classes per day, which starts from 8 a.m. And what is the prerequisite for data science? I would say just a basic understanding of the programming and little understanding of maths. For AIoT, I would say basic understanding of program and electronics and time. So last date to apply is 25th of November. Aptitude test is 1st December, which is Sunday, and it is tentative date. We will be taking an aptitude test for 1 hour, and all things will be online. Interview will be taken. We will be giving few days for the interview. 6 to 9 December, we will schedule the interviews. Again, you will be, giving the interview on AI platform only for 20 to 30 minute slot. You can choose as per your convenience. And we will start with our next batch from the first week of January. And that's it about the programs. Any questions about Sabud and STPI program that we run for data science and AIoT? Any clarity? So aptitude test, the level. See, I will just share again my screen. You can take the screenshot, or Priyanka can put the link of the Sabud website in the chat also. So this is our website, sabud.org. You can go, see, this is the, just on the homepage tab, you can download the brochure. The complete information is there. Internship tab, there are data science and artificial intelligence tab. Just click on data science. This is the registration form. See, you can, fill the your information. Since you all are coming, maximum of you are coming through STPI, so you shall, select yes. Are you applying through STPI? Yes. So another, tabs will open for you. You need to mention from which STPI center you are and state and college. Okay, so this is the registration form, and most of your queries will be solved through our FAQ, which is on our website. So general queries are there, learning platform related queries, awareness workshop, and aptitude test. Now, what is this awareness workshops? See, like today we conducted a webinar. This is also one kind of awareness. On 9th and 10th, we will be conducting awareness workshop. One full day, the registered people or non-registered people, they will spend with us one full day for Python programming sessions and another full day for data science sessions. So this will be 9th and 10th, that is Saturday and Sunday. So suppose you are registering yourself for the program, either AIoT or data science, you will get an automated email. In that email, you can see the WhatsApp group link. We have, the important dates also there in the email. So better you join that WhatsApp group and we will be giving you the information regarding the workshops. Okay. So more time explain us. Okay. Yes. Thank you. We will take care of this thing, Sham. So Priyanka, I think that's it.
Yash
So
and
that's it.
Gurkirtan have a question.
Right.
There is
Gurkirtan, you can please unmute and ask.
Good afternoon, ma'am.
Yes, please.
Ma'am, I am a student of batch 12 actually, and I was in the part-timers batch. I just wanted to know when our project will start because my exams are coming of the end semester and
So
it will be difficult
Gurkirtan,
for me to catch up.
yes, Gurkirtan, I think this is not the right platform to take this question, but I will be telling you if you have completed all the modules. So this was the condition for the part-timer. If you have completed all the modules, you will be receiving your certificate. Just drop an email on admin that you are interested for the project. Then we will be, involving you for the project. Right, Gurkirtan?
Oh, thank you, ma'am. Thank you.
Thank you. Thank you.
Ma'am,
So,
I've got a small question actually.
right.
In the curriculum that was shared in the brochure, it says that data science is a 6-month course, right?
Yes.
And we've got multiple sub classes in it, like Python programming and machine learning, right?
Right. Right.
Now, next to Python programming, it shows as 6-week course, and machine learning is 12-week course, right?
Right. Right.
And
Right.
when you add all of it, it comes to, I guess, 67 weeks. So I was just confused.
Yes, so it will start parallelly. We will start
Okay.
machine learning and Python together. Once we conclude with the Python, we start with the deep learning. Then two modules will be running parallelly, deep learning and machine learning. Once we conclude machine learning, we will start with NLP. And throughout the 6 months, data structure and algorithm will go on throughout the 6 months. And project again, it will run for the 6 months. Data IQ certification we start, after suppose you are settled down in the batch, and after 1 month we start with data IQ certification. So modules they run parallelly.
Okay, ma'am, this passion project, so it's not happening at the end of the thing. It's
No, it will run for the whole 6 months. Like we start
okay.
with passion project after 15 or 20 days only. Once you registered, you enrolled in the program.
Okay, so out of all of the passion products, I get to choose one, or is it all of them?
See, we do have a list of the project. We will be sharing that list of the project with you. And with the list, we will be sharing the technology involved in the project. So you will be choosing the project as per your interest. We will make a team of 5 to 7 people. They all will work together for that particular project.
Okay, thank you. Ma'am, just one last question. So
Right.
I've
Right.
got very basic knowledge of JavaScript, right? So is that sufficient for this project?
Right.
Because
Yes, it is. It is sufficient. So just, any programming language is sufficient. Any, है ना? So suppose if you have basic understanding of maths, because data science involves statistics and maths. So if you have that, little understanding, then it is suitable for you. But yes, the important thing is you shall devote time for this internship, because I have mentioned the time commitment is 48 hours per week. So sessions we do run only 2 to 3 session in a day, sometimes 2 session in a day only. But the maximum hours we would need from you for your learning and practice, for the assignments, for the coursework, so that we will be sharing with you.
of course, ma'am, I understand.
Right.
Thank you so much. Thank you so
Thank
much.
you.
This was very
Thank
helpful.
you. Thank you. So I guess, Priyanka, we can wrap it up now.
Okay, thank you, ma'am. Thank you, everyone. Please fill the feedback form we've shared in the group chat before you leave.
Thank you, everyone. Thank you for joining the session.